Good afternoon, everyone. Welcome to today's Tech Tuesday. My name is Vanessa with ITS Communications, and today we are going to be talking about Research Cloud with two people from our informatics team, Nev and Sajad. Before we begin, I just wanted to let everyone know we are recording today's session. So if you'd like to go back over anything that you may have missed, or even want to share this with some of your colleagues who may have been unable to attend today, you'll get a follow-up email after today's session, and you'll be able to see the link to this recording as well as other resources to get you started with Research Cloud. We also have everybody on mute just to prevent any background noises. But if you have any questions during today's session, please feel free to put them in the chat. Or if you'd like to come off the mic to ask your question out loud, just hit the raise hand button in your under the React toolbar option, and we will see your hand raised and be able to take you off the mic so that you can talk. Without further ado, I am going to have pass it off to Nev first. Nev, thank you so much for joining us.
Thank you so much, Vanessa. And again, everyone, welcome to this Tech Tuesday session. So as Vanessa said, my name is Nev Chang. I'm a data operations manager for research informatics. And I also have my colleague Sajad Abedian, who is the data science services manager for research informatics. And today we will be presenting on how to harness the power of research cloud computing. We will talk about how researcher informatics under architecture for research computing in health, more commonly known as ARCH, can assist. Just to give you a lay of the land and brief overview of the agenda, we will start by discussing examples of research cloud environments and cloud services in general. Then I'll turn it over to Sajad to do a demo of a cloud environment. And then finally, we will end with showing you how you can submit a request with us and what the life cycle of your project will look like from the initial request to ongoing maintenance and project closure. We will have pauses during the presentation to check the chat for any questions. So I'm going to go ahead and kick us off now. So ARCH enables Weill Cornell investigators to obtain electronic patient data and accelerate scientific workflows. With support from both the CTSC and JCTO, the ITS Research Informatics team manages the ARCH suite of tools and services that you see here. We provide comprehensive support for clinical and translational research. As you can see, services include, but are not limited to, electronic health record data collection, electronic consent for research participants, biobank management, mobile apps for research, natural language processing, and artificial intelligence. Today, we are here to discuss Research Cloud specifically. So you are probably asking, what are some examples of this? So cloud environments can be used for many use cases, both basic or clinical research. You will see that some of my examples lean towards clinical research because those represent the recent cloud projects we have worked on. The first example is if you need assistance with storage of data. Let's say I need to store 4 terabytes of scanned mouse MRI images. Or I need a GCP environment with Vertex AI enabled so I can use LLMs to query clinical notes. A recent example was that a researcher wanted to test a new app using a machine learning algorithm to see how therapy adherence can be improved. To speak more generally, research informatics specifically works on supporting cloud environments that have some sort of institutional determination and approval. For example, most of the cloud environments we have built are for IRB-approved research studies. And in these situations, we have reviewed the IRB protocol to ensure that the cloud environment is covered under the regulatory documents before we get started on the technical specifications. We do have a multi-cloud model, meaning that we support different cloud platforms. As of now, we support Amazon Web Services, AWS, and Google Cloud Platform, GCP. ITS provides centralized oversight of any cloud services that we provision for you, meaning that we ensure governance, compliance, and alignment with our organizational policies and standards so that you don't have to worry about those elements. And we wanted to highlight that there is a lot that goes on behind the scenes to support research cloud environments so that we are in alignment with our policies and standards. ITS can take a lot of the worries away from you that come with maintaining a secure environment. We bring in a lot of infrastructure and support to maintain this environment in accordance with institutional standards. And you can see the creation of the environment is just one of the many aspects. So starting at the bottom of this stack diagram, ITS provides the infrastructure to support these environments by providing network and operation support. We can ingest and sync the data that you would like to host in the cloud environment. We also conduct the necessary security reviews. And after we internally review the environment, we would work to provision you access and release the environment to you. And we conduct user acceptance to ensure that the environment meets your needs. In addition, we keep up with the updates and patches to the environment to address issues such as bugs, security vulnerabilities, or to improve functionality of your environment so that you can use your cloud environments with peace of mind. Which is why if your data classification is moderate or high risk, then you must engage with us so that we can work with you to provision an ITS managed account. Our business associate agreements with Google and Amazon ensure that the data we upload will be protected and not shared with other sources. And it can be tricky sometimes, but if you need assistance in classifying your data, then you can always reach out to our team for help. And you can do that by emailing arch-support@med.cornell.edu. I will pause right here to see if there are any questions, but once we address any questions, I'm going to turn it over to Sajad to do a live demo of a cloud environment. Okay, I don't think there are any questions at the moment, so I'm going to turn it over to Sajad.
All righty. Thank you, Nev. Okay, so today I will be demoing an example of a project in GCP, and I'll walk through your GCP dashboard. Um, but keep that in mind, you can also request AWS account and have access to AWS. For the most part, when it comes to just cloud services, whether it's GCP from Google or AWS or even Azure, all of these basically sit on the same foundation. They might have different names, but the use case will be fairly similar. Um, so in order for you to get access to your GCP, and Neb is going to go through this, how to request access, how to set up a project. But once you are added to your project, you can log in by using this console.cloud.google.com. If you have not logged in before, I am logged in, you will be prompted to put in your email and password. What you should be doing is you should be logging in with your seaweed, so the admin.cornell.edu email address that you have, and after that, you will be prompted to put in your seaweed and password the same way that you do it for any other websites within Weill Cornell's network, and you will be asked to put in a duo factor authorization and so on, and you go through that. Once you're there, you will be faced with this page. Over here, you most likely will land on, if you only have one project, it will be the only project that you have. If you have multiple projects, it will be automatically logged into the last project that you've been using. If you're part of multiple projects, you can click on this button right here on the top left, and you will have a list of all the recent projects that you worked on. You can also star them if there's a project that you're using more often than the others, and then there's also all the projects that you're part of. So for this one, I will be using RI Sandbox. Once you're in your dashboard, there's a way to navigate the dashboard. This might look overwhelming. Fortunately, you will not, or fortunately or unfortunately, you will not have access to everything here. We want to make sure we can provision minimum access necessary to all these cloud environments. But the main things that you most likely will have access, depending on your use case, is the ones that I'm going to go through. So the best way to navigate that is you could either look for the specific thing that you're looking for here, or you can click on the hamburger button on the top left. And over here, you will have the same options that you're seeing on the screen in your dashboard. I'll start with BigQuery. To set the stage for BigQuery, if you've ever worked in a relational database, um, you will not have a problem working here. Essentially what BigQuery is, let's say if you have a project that requires data from a cohort of patients and the data consists of different tables. For example, you have a table for diagnosis, you have a table for encounters, you have a table for labs. What we can do is to work with your team and our data engineering team to ensure all the tables show up here. For this project, we don't have anything that is PHI related, so I won't be able to show you anything here, but I do have an example table. So I will open up this table here. It's in another project. And as you can see, this is your database. And under every database, you have a table. So in this example, I only have one table, empty cars example. And you can get a preview of like the first, I think it's 10 rows of your table. And if you are up for it, you can write a SQL code against that. One thing to note for those of who are familiar with SQL, this is a Postgres SQL flavor. And if you've ever worked with our team and you have access to our data, you most likely have been using Microsoft SQL Server. So the syntax might be slightly different, but that should not be a problem. And if you have any questions about changing the syntax from whatever projects that you have working with us on your on-prem projects in our servers, we can also help you with refactoring your code to write it against this flavor or this syntax of SQL. But yeah, over here you can write your SQL codes if there's any where statements, and once you hit run, you will be able to get results based on the table that you're querying. So that's one use case, but that's not the most exciting use case of the cloud. So what I want to show you today here is how to write code or how to write API calls against LLMs, large language models. So the best way to do that, you do have the access to write a query against Gemini model in a free form, the same way that let's say you open up ChatGPT and you're using it for your personal use cases, there is going to be an option for you to do that as well. But let's talk about how to write actual code, most likely Python. My suggestion, and I'm very biased against that. So let me open up. We just leave this page. I'll go back to my hamburger button here and then Vertex AI. So if I click on Vertex AI, you will have a lot of options. The main one that you want to go to, at least to start with, is to Workbench. In the Workbench, there you will have at least one default instance here. And the instance, you can think of it as a virtual machine that you can spin up whenever you need, and you can stop it whenever you're done with your work. And it's important to note that you should always stop this instance, and I'll show you how to start it and how to stop it, because that will cost you money. For every minute that this machine is spun up in your virtual Google Cloud environment, this will cost you. It is not a expensive load on your total project cost. These machines are depending on depending on the type of the machine, it can range anywhere from a couple of cents to a little bit close to $1. But usually what we do here is we suggest to spin up a default or the minimum necessary machine type. So as you can see, for CPUs, 16 gigabyte of RAM is not going to cost you that much money. But once you have that set up, and again, you have to work with us and the cloud team to pick the type of machines that you need based on your use case, and then we will create these machines for you. Once the machine is available for you here, the virtual machine rather, you can select it here and then click on Jupyter Lab. And it will take a couple of, hopefully a minute or two to start. And while you're waiting, I can talk about the rest of the things that you see here, and then we can go through them. GCP offers different data sets. They're publicly available data sets, so you can always use those. There's also a lot of help with how to design your prompt So there's a lot of creative ways to design prompts. So I highly recommend checking out the prompt gallery here. There's also a way to basically, with the help of AI, to create a prompt for AI. So the create prompt also helps you to test out some of your prompts here as well. There's a lot more advanced tools here. If you're creating an agent in your Google Cloud environment, there are a lot of tools here as well. And as you can see, there are a lot of ways to deploy your models and develop your models and run them not only as a one-off, but also schedule them and so on. So let's wait a couple more seconds and hopefully this instance will be ready for us to use.
There is a question in the chat,
Oh,
Sajad.
sure, yeah. Let's address that.
Can we not configure to shut down VM when the VM is idle for more than a minute or 5 minutes?
Very good question. It's already defaulted. I'm forgetting exactly what is the default time, default idle time, but it will shut down by itself. So you don't have to worry about it. We have implemented that part as well. So if you forget to close your instance, it will shut down by itself. But recommendation is always try to shut it down yourself. Okay, now this is ready, and the way that I know it's ready because the status itself says active. So I will click on Open Jupyter Lab again, and I will start working. So for those of you who have written any code against Python, especially using Anaconda or Visual Studio Code, in general, working with any Jupyter Lab, Jupyter Notebooks, you should be very much familiar with this. So let's start off with your directory. On the left side, what you will see here is a directory that you can possibly organize yourself. So if you have multiple projects, you can have multiple folders here. One thing to keep in mind, if you have more than one user in your GCP, which most likely you will have, everybody can see this directory. So you should be able to, let's say, share codes or tell somebody, my code is in this folder or the data is in this folder and so on. So everybody should be able to use the same directory here. And you can have more than one person or one user use the instance at the same time. So it doesn't have to be only one person. So if you have already spun this up, if somebody else wants to also open this Jupyter Lab, they can, and they can work in the same environment as you. A couple of things here is that you can possibly create different types of notebooks. As you can see, there's R capability, there's TensorFlow, and there's also the Python and the specific PyTorch. You have access to a terminal, and so on. I see another question in the chat, so I will go ahead and okay. Yes, thank you, Evan. Great. And then what I do suggest here is that always make sure any data that you import or you export out of this GCP goes through a tagged device. Anything within GCP, you're fine. You can have PHI here. But let's say if you want to export the data out of GCP, make sure if you're exporting to your tagged device, especially if it has PHI. So I'm not going to go through the code itself. For those who are familiar with Python, this should not be a problem. We are happy to share some code examples here as well. But I just want to demonstrate how easy it is to write a code against a AI model. All you have to do is set up the model configuration, instantiate your model itself, and you have many options. And I'm going to go through the model garden, the catalog of all the models that you have access to. But once you have your model set up, it's just as easy as just setting up your prompt. I'm asking very specific questions here, and then I can run this AI model against the tables that I have. And as you can see, I'm processing quite a large data set here with about 1,100 rows, and it did not take more than 10, 11 minutes. Of course, if your notes are a lot bigger, it might take a little bit longer, but it really depends on the model and how you have set up your pipeline. But more often than not, it's going to be very fast. And going back to performance, I would always advise against beefing up your machine type unless you are very sure that your model's performance is being constrained by the GPU, by the CPUs, or by the number of RAMs that you have here. A lot of times, what I have seen is that you can change your Python or your pipelines code and make it faster rather than just beefing up the machine type. Um, Especially if you're working with parallel computing, sure, you definitely need more CPU cores. But for the most part, at least in your development stages, you most likely won't need that. The rest of this code is really just a bunch of Python magic, so there's no need to really go over it. But a couple of things here, as I mentioned, you can export the data as easy as right-clicking on this and downloading it, and you can also as easily import data by essentially just drag and dropping things. So I'm gonna try to do something here. Let's see if I can find something here. Great. So I have this SQL code and I want to bring it here. I can just drag and drop it, and the SQL code is right here. So you can very easily bring any code that you have already on your machine into your environment. And as simply as that, I can delete it. So this is a very quick overview of how to spin up a workbench, how to work in Workbench. But let's talk about all the models that you have access to. So in the example that I showed you, I was using Gemini 2.0 Flash. But if I look for Model Garden here, you have access to all the models that have been developed by Google by default. You can see you also have access to Llama, and then depending on the company itself, Mistral AI, and Anthropic is the another partners that is working with Google to make their models available. Um, I do advise against using any model that you see here without consulting with our cloud team, unless it is a Gemini model. Gemini models are available across all the instances, but when it comes to some of these very niche models like Anthropic or Mistral AI, you may have to deploy the model into your instance because they're not already part of your instance. And for doing that, it may cost a lot of money to deploy those nodes into your environment. So I do advise to reach out to the cloud team to talk to them. Hey, is this model already available in my instance? If not, how can we make this available, or should we even make this available? Or are there any other default models that are currently in the environment that I can use instead of going down the rabbit hole of looking at Meta's models or anything like that? But as as I said, there's all the Gemini models that you could possibly use, and we have not had any problem, at least in our development stages, to use those. So I will pause here. So this is a very quick overview of how to go into your GCP and use the main two things, the BigQuery as well as the Vertex AI, to get your work up and running. Any questions? I'm looking at the chat, but also feel free to unmute yourself. All righty. So what I will do, I will follow best practices, and I'll show you how to stop the instance. So I'll go back to my Vertex AI, so we don't have to wait 1 hour for the idle time to elapse. So I'll go to the workbench, and I go here, and if you click on stop, your instance will stop and it will not accrue any money anymore. And with that being said, I'll pass it back to Nev.
Thank you so much, Sajad. I'm going to continue because I don't see any questions in the chat as of now. So now what we will show you is how you can get started if you would like to explore using a cloud environment. So the research informatics team has designed specific forms to group the variety of requests we fulfill to ensure we get all of the necessary information from you to reduce back and forth. So we've listed a few of our most common forms here where you can, for example, request cohort discovery tools when you want to get counts of patients for your specific research aims at the very beginning of your research. And these tools, for example, are really great for determining study feasibility. As you can see, we have a separate form for REDCap assistance. We also have a report request form if you are looking for rows and columns data through custom reports. Highlighted here is the form that we want to focus on today. This is the one you'll need to kick off the process to explore setting up a research cloud environment. And this form is called Research Computing Storage Request. This form is actually one of our newer ones, and we purposefully designed it to be broad so that you can submit a wide variety of use cases. Here's some key information we need to get started. So you would need to first provide a project title and your scientific objective. You would need to provide us with your data classification, as we discussed before, whether it's low, moderate, or high, and we can account for the necessary controls and parameters needed within the environment. There's a free text area where you can outline your requirements for this environment so that we can help determine which technical environment and solutions would be best for your purposes. And Sajad touched on the billing and the fund number, but this is not included in the form. But this is something you should keep in mind to cover potential costs for your project. And we will be asking you to provide one if we are designing a technical solution that will incur costs. And I have put a link to the research computing storage request form here. So once you submit that request to us, what can you expect from? So someone from Research Informatics from our team will contact you, and we will set up a meeting to discuss your request further. If needed, we will draft up an acknowledgement document that outlines the purpose and the agreements of use around the environment. So I have added screenshots of some of the questions in the document just to give you an idea. This acknowledgement document contains detailed information about the usage overview, the technical details behind the build, who the users will be, and what level of access will be provisioned to each user. This document is really important from a regulatory standpoint in case we get audited so that we can ensure both parties have agreed to the use and purpose of the environment. Either the principal investigator or the head of the division or department will be required to sign, along with a member from research informatics leadership. And at this time, we would also ask you for the fund number if the project will incur billing costs. So once we have the acknowledgement document finalized, the technical build will begin, and we will keep you notified as progress is made. And before we provision you access to the environment, every member will need to sign an additional document, which we call the attestation document. And that basically just bullet points and outlines the parameters that you are agreeing to follow within the environment. And of course, you don't have to remember all of these steps at this time. Once you kick off the process with us, we will walk you through it step by step and remind you of what the requirements are. So as you saw from the stack diagram above, ITS not only provides the infrastructure to support and maintain the environment, we also take into account any operational change management and closure. So once we deliver your environment and we have passed user acceptance and you tell us this is what I need, this looks good, we will mark your original research computing and storage request as completed. However, you may need additional users added to the cloud environment at a later date, or your needs may change and you may request updates to the original environment build. For these updates, we would require you to open up a new research computing storage and request form so that we can track your request properly. And you would basically outline what your new needs are. And we would, again, go through our process and make sure that all of our documents are updated accordingly, attestations are signed, and we would, again, walk you through this. You can always reference the original request as well, because that would be very helpful for us to go back and take a look at what was already provided. For any new members that need to be added, we will check whether they're authorized to access the environment. In the example of research cloud environments that we have recently provisioned with that have an IRB approval, as I mentioned, we do check whether the user has been added to the IRB protocol number as personnel before we provision access, in addition to gathering the attestation. And then for any updates requested to the environment, we would also recheck to make sure institutional approval covers these changes. And then finally, there will come a point where you will close out the project on your end officially. And in those cases, ITS can also assist to ensure you're archiving the data properly. We would connect you to our colleagues in the library who manage research data management and retention. So with that, we hope you found this presentation helpful, and we would love to open up for any questions at this time.
Thanks, Nev, and thanks to Jad. While we're waiting for any questions to show up in the chat, I just wanted to point out that Cindy's also posted some important links that you can take a look at for the request form, as well as our data classification policy. And for those who signed in late, we are recording today's session. We usually get questions about that in the end. You will receive a copy of the link in your email after the session is complete. And if you have any questions and want to come off the mic, please feel free to hit the raise hand button or just type it in the chat. Looks like we got one, Nev. Is it okay to submit a request to spin up a sandbox environment setup, either in AWS or GCP for dev work?
Yes, we have done that recently, so it's perfectly fine. We would just work with you to again understand what your use case is, whether whether AWS or GCP would be a better fit, what you're looking to do, and definitely we can work with you on setting that up.
Thanks for that, Nev. If I could just chime in briefly. Hi, folks. This is Evan Scholl. I'm the Associate Director of Research Informatics Data Science Services. The one caveat I would issue there is that the dev work would have to stay dev work until you have like IRB approval. So as Nev mentioned, we have some paperwork as part of this. We would sort of describe the environment as a dev environment and say, I understand that I'm not going to work with any protected health information or any sensitive patient data, until and unless we get IRB approval. But yeah, as Nev said, it's totally fine to request the creation of a sandbox environment for dev work. Really, what we need in order to get started is a fund number in order to cover the costs associated with the work.
Yes, thank you, Evan. So basically, we would have you would initially initiate the research computer request as a dev environment. We would fill out the paperwork in that way, and then when you're ready, you would submit another request, and then we would update the existing documentation to reflect all that. So we would just follow the process that was described, and we can walk you through that once you're ready.
Yeah, and if you don't want to work with sensitive data, that you may be able to get started right away. For example, if you have, a mouse data set, we might be able to get you started right away. I will say that, there are also other venues to do high performance computing at the institution. Would really sort of encourage folks to reach out to us and talk to us, and we can try and suit you with the best tool to fit your need.
Yeah, that is a good point, because based on your use case, cloud may not be the best. So that's why we set up a call with you to understand what you're trying to aim for, and then we can match you with the right tool. And thank you, Cindy, for posting. That's the email that you can reach out to us by arch-support@med.cornell.edu. That's a good email to reach out to if you're not sure what you want to do yet. You don't want to open up a research computing storage request yet, but you just want some information, and then we can guide you to the appropriate request form.
Are there any other questions that anybody has before we wrap up today's session? Let's give it another minute or so. While we're waiting, I just wanted to thank Nev and Sajad for joining us today and teaching us more about Research Cloud. Again, I will be posting the links that are in the chat as well as the ones discussed in the PowerPoint presentation. I'll make sure to send all of that to you guys in a follow-up email. So no worries if you haven't had a chance to write it down. You will be receiving everything. I don't see any questions, but I just wanted to remind everyone that if you do have one after the session, please feel free to just hit reply on the follow-up email as well. We'll make sure it gets to the right person so that you can ask, any questions you have about Research Cloud or any of the Arch services that you may find use of in your own work at Weill Cornell. I'm going to wrap up today's session. Thank you so much to our facilitators for joining us, the research informatics team in particular. I know that there are a few people on like Evan and Cindy who've been helping us out. And I will be sure to send you all of this in just a bit. So thank you so much. Have a great rest of the afternoon and thanks for joining us. Thanks, guys.
Thanks,
Thank
Vanessa.
you.
Thank you.